Hello viewers, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungudi from C.D. King Higher Secondary School, Science Stream, Jotsama, Kohima. In the last sessions, we have learned matrices and algebra of matrices. In this session, we are going to learn determinants. Whenever we see chessboard or Sudoku in the Nagaland post or the arrangement of chairs in your classroom or any other programs, we will remember matrices. Determinants were used long before matrices. It was defined as a property of system of linear equations. In our lower classes, we have studied the system of linear equations and how to solve it and the solutions. It may have a unique solution or infinitely many number of solutions or no solution. The determinants determines the uniqueness of the solutions. We all know who introduced COVID-19 to the world. The same people, they first used these determinants in their mathematics textbook in the name the 9 chapters on the mathematical art around 3rd BC. Later, Wander, Monde and Laplace, they made their contributions. At present, matrices occur throughout the mathematics. Today we are going to, in this session, we are going to learn determinants in detail, how to find the values and how are they useful in finding the area of the triangle, and later the properties. And in coming sessions, we are going to learn how to solve the system of linear equations using determinants. Let's start with the portion here. Determinants. First of all, let's see what is a determinant. Determinant. It's a unique number. It's a unique number. It may be real or complex, associated with every square matrix. Square matrix. We already have learned what is a square matrix. Let us recollect it. Square matrix means the number of rows is equal to the number of columns, that is m equal to n. And here it is a unique number. It may be real or complex, associated with every square matrix. So it reminds us the definition of function. What is a function? If there is a set A and set B, here the elements A, B, C, D or whatever it is, here X, Y, Z, etc. If we define a relation F, then F is a relation from A to B defined by, or F of A equal to B is called a function when every element of A has a unique image in set B. Then we call this as a function. Similarly, it reminds this. See, a unique number associated with every square matrix. Now we put all the set of all square matrices in this set. Let us name it as M. See, A is a square matrix, B, C, D, so on. And in another set, let us name it as K, we put all the numbers, real or complex numbers. Let us name it as K1, K2, K3, etc. What we have told is here, a unique number associated with every square matrix. So every square matrix has a number there. So we can map like this. Isn't it? So it is a function. If f is a function from m to k, then we define this function as m is a function from m to k by f of, suppose A, if I take the matrix A equal to k1. Then this f of A is called the determinant of A. Hope you understand. What is a determinant? Determinant is a unique number associated with every square matrix. And also it clearly says that if the determinant exists only for the square matrices, not for the rectangular matrices. We cannot find the value of determinant for rectangular matrices, only for the square matrices. Okay. And the determinants are denoted by, suppose A is a matrix, 2, 3, minus 1, 0. This determinant, if we find the determinant of this matrix, we denote it as determinant of A, DETA, or determinant of A, or using this small triangle symbol. It denotes here determinant. And determinant of, this is not modulus, it is determinant when A represents the matrix. Yeah. Then we will see one by one how to find a determinant for square matrices. In class 12, you will be learning to find the values of the determinant up to 3 orders with real entries. And in higher studies, you will learn more. So first let us find out for the square matrix of order 1. Let it be like this. This is a 1 by 1 matrix. It's a square matrix. Then let it be A. Then how to find the determinant of A? It's just this value. Yeah, that's all. Then let us take another matrix, 2 by 2 matrix. 2, 3, minus 1, 0. Then how to find the determinant of B? We denote this one as 2, 3, minus 1, 0. See, you have to look carefully. Here we have used the closed bracket, but we are using only the bar symbol here. We cannot say that it's a bracket, it's just 2 lines, parallel lines. So we can remember it as a bar. We should use this whenever you are finding the determinant value. Okay. How to get this value? We'll start from the left top, and you multiply these 2 elements. So 2 into 0, right? Then minus, put minus, then you multiply these 2 elements. So this is 3 into minus 1. So it gives us 0 plus 3, that is 3. This is how we get the value of determinant of a square matrix of order 2. So we multiply in cross way and subtract it. So this is the determinant of square matrix of order 2. Before moving on to the 3 by 3 matrix, we have to learn some signs which we are going to use for the 3 by 3 square matrix. Let us take A as 2, 3, minus 1, 0, 4, 2, 5, 1, 6. Now we are going to find the determinant of this matrix. 2, 3, minus 1, 4, 2, 5, 1, 6. Determinant of this one, this matrix. Okay. So there are 6 ways for evaluating this determinant. 3 ways along 3 rows. So we can evaluate over this, along this row, or along this, or along this row, or maybe by these columns, 3 columns. So there are 6 ways for us. If you follow any way also, you will get the same answer. It's up to you. But before that, we have to remember these signs. If I tell you mathematically, it will confuse you. So I will just tell you in short. So plus, minus, plus, minus, plus, minus, plus, minus, plus. We have to remember these signs for evaluating the determinants. Suppose when we are evaluating along this row 1, we will take these signs. And when we are evaluating along R2, then we take these signs. And R3, we take these signs. And C1, we use these signs. This one, C2, and this is for C3. Okay. Now let's see how to find the value of the determinant along R1. Okay. So what are the signs we are going to give? Plus, minus, and plus. So here, plus, minus, and plus. Plus 2. We take that element and see, deleting its column and row, where it presents. See, we are taking this element. So you just delete this column and row. So you delete this and this column. So we have remaining 4 elements. So you can form a 2 by 2 determinant. See, 4, 2, 1, 6. 4, 2, 1, 6. Then the next element. What is the next element? Minus. We use minus. Here we use minus, and then the element is 3. Now, how we did for the first element, similarly we do here. We delete this column and this row. So we have remaining 4 elements, that is 0, 2, 5, 6. Then the last one, plus of minus 1. Here also if we delete this column and row, we get the remaining 4 elements, that is 0, 4, 5, 1. Now it is easy for us to find the value. We know how to evaluate this 2 by 2 determinants. So plus 2 into cross multiply and subtract it. 24 minus 2, then minus 3 into 0 minus 10. Then I have multiplied like this. Plus of minus 1 is minus 1, then here 0 minus 20. Then 2 times 22 minus 3 into minus 10 minus 1 into minus 20. So it will be 44 plus 30 and plus 20. So that is 94. This is how we evaluate the determinant for 3 by 3 matrix. So we have expanded this, expanding along R1. We expanded this determinant along R1. Let's check what will happen if we expand along C3. C3. Our answer is 94. I want you people to remember this answer. C3. So in C3, what are the signs we are going to use? Plus, minus and plus. So this is plus, this is minus, and this is plus. So we will take that determinant of A is plus of minus 1. We should not forget to multiply this element. Sometimes the students miss to write this element. Directly they take the 2 by 2 matrix. Then we delete this column and row. So we have these 4 numbers, elements. So 0, 4, 5, 1. Then we go here, that is minus 2, and here this row and this column. This row and this column. If we delete it, we get 2, 3, 5, 1. Then plus 6 into, then when we take this element, we delete the column and row. We get 2, 3, 0, 4. 2, 3, 0, 4. So here minus 1 into, if you cross multiply, we get 0 minus 20. And then here minus 2 into 2 minus 15. 2 minus 15. Then plus 6 into, if we multiply cross, 8 minus 0. So we get plus 20, then minus 2 here minus 13, so plus 26, then here plus 48. So 68, 94. We get the same answer. So you don't need to worry if I evaluate along any other row or column whether I will get the same answer or not. You don't need to worry. So you will get the same answer if you expand along any row or any column. Next, we will solve some problems from the exercise. Evaluate the determinants, this one, cos theta minus sin theta and sin theta and cos theta. So it's a 2 by 2 determinant, so it's easy for us to find the value. So we just multiply in cross and then subtract it. So let it be delta, that is equal to, if we multiply, we get cos squared theta, and here minus sin theta minus of minus sin theta into sin theta, sin squared theta minus sin squared theta, then cos square theta, minus of minus plus sin square theta. We all know this identity, sin square theta plus cos square theta is 1. So, that is all. This is the answer. The next one more problem. If A equal to 1, 2, 4, 2, then show that determinant of 2A equal to 4 times determinant of A. Okay. So, here the matrix is given. We have to show that determinant of 2A is equal to 4 times determinant of A. First, let us find out the LHS value, then we find the RHS value, then check whether they are same. So, to find LHS, we need 2A first. Let us find out 2A. This is a scalar multiplication. So, 2A, 2 times of A, 1, 2, 4, 2. So, this will be, we just multiply 2 inside with all the elements, that is 2, 4, 8, 4. 2 into 1, 2 into 2 and 2 into 4 and 2 into 2. So, this is 2A. Now, let us find out the determinant of 2A. This is our LHS, left hand side. So, that is determinant of 2, 4, 8, 4. 2, 4, 8, 4. Then, how do we evaluate this? 8 minus 32. So, this is minus 24. Let us keep this as 1. Then we will move on to the RHS. So, in RHS 4 times determinant of A. First, let us find out determinant of A, then we multiply with 4. So, determinant of A is determinant of 1, 2, 4, 2. So, that is, if you cross multiply, we get 2 minus 8, that is minus 6. Then our RHS is 4 times determinant of A, that is 4 times minus 6. So, that gives us minus 24. This is 2. See, our 1 and 2 gives the same answer, that is LHS equal to RHS. Therefore, from 1 and 2, LHS equal to RHS, hence proved. Next one, let us learn how to find the area of the triangle using determinants. See, in your lower classes, you have studied this formula, long formula. Often you used to get confused. So, half of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. This formula you have studied in your lower classes. So, now the same thing we can write it in determinant form. So, that is area of triangle is determinant of half into x1 y1 1, x2 y2 1, x3 y3 1, where this x1 y1, x2 y2, x3 y3 represent the coordinates of vertices of the triangle. Square units. If you expand this determinant, how we learned earlier, if you expand this determinant, you will get this formula. Now, it is easy for us to remember. The same formula, we can use it like this. So, already we know 3 points, say A, B, C, A, B and C are collinear if and only if area of triangle is 0. This we have studied before. So, what do you mean by collinear? The points lie on the same straight line. So, in that way we call this as collinear. If the points lie on the same straight line, then we cannot form a triangle. Therefore, the area of triangle it is not possible for us to find out. In that case, the area of the triangle will be 0. So, in that case, we can say that the 3 points are collinear. Okay. This is if and only if. If you take that the 3 points are collinear, then area of triangle is 0. If area of triangle is 0, then the 3 points are collinear. Then one more point. Since the area is always positive, we cannot find the negative area, so it is always positive. If you expand these determinants, sometimes we get negative values. In that case, we take only the value, that is the magnitude, we avoid the signs. That is, you can easily remember that we always take the positive value, even if it is negative. And sometimes you will be given the area value, area of the triangle is this much, and find the missing vertex or something like that. In that case also we have to take the area with both positive and negative value. We will see one by one that from by how to solve those problems. Okay. Find the area of the triangle. Find the area of the triangle with vertices 1, 0, 6, 0 and 4, 3. These are the 3 vertices of the triangle. Okay. The given vertices are A, let us name it ABC, B 6, 0 and C 4, 3. Now we have to find area of the triangle. Area of triangle ABC. Or we can use only this symbol. We are going to do the determinant, so we can use this. So half times the value, the formula, how do you write? x1, y1, 1, x2, y2, 1, x3, y3, 1. Square units. Units are important. Then half into, here the given vertices, we will take it as x1, y1, and this is x2, y2, and this one is x3, y3. Let us substitute this. 1, 0, 1, and here 6, 0, 1, and this is 4, 3, 1. x1, y1, x2, y2, x3, y3, then these are 1. Okay. Then here we have to evaluate the determinant. I used to give a simple tip for you. See, you always try to evaluate the determinant along the row or column which has many number of zeros. Then it will be easy for us. See, here we have 2 zeros in this column, isn't it? If we evaluate along this column, it will be easy for us to get the answer. Because 0, we multiply the elements also with that 2 by 2 determinants. In that case, it will become 0 automatically. So it is easy. So when we take the second column, the signs, hope you remember, this is minus and this is plus and this is minus. Yeah. So we take this. Just I'll show you here how it becomes 0. But next time you can directly write 0. So minus 0 into, if you delete this column and this row, we get 6, 1, 4, 1. And if you take this 0, if you delete this row and this column, we get these 4 elements. So 1, 1, 4, 1. And if we expand this, if you delete this row and this column, we get 1, 1, 6, 1. See, here this is 0 into this determinant. This is 0 into determinant. Whatever we get, when we multiply with 0, it becomes 0. Here also the same. That's why I told you people to expand along the row or column which has maximum number of zeros. So we can avoid these two. We can directly go for the third one. That is half into. The first one is 0. The second one is 0. The last one is minus 3 times. We evaluate like this. So 1 minus 24, so that is, 1 minus 6, 1 minus 6, so we get half times, so this is minus 5 into minus 3 plus 15. Luckily we are having plus 15 here. Suppose if we get minus 15, so we will take only plus 15 only. We treat it as positive. So 15 by 2 square units. And please don't forget to write the units since it's area. Okay. The next we will show the 3 points are collinear. Show that points A, comma B plus C, and B, comma C plus A, and C, comma A plus B are collinear. Okay. How do we show these 3 points are collinear? If we show that the area of the triangle is 0, then we can say that the 3 points are collinear. Yeah. You can write the given points are A, B, C. The given points are A, comma B plus C, and B, comma C plus A, and C, comma A plus B. So this one we will take it as x1, y1, and this is x2, y2, and this is x3, y3. Yeah. Let us write the formula. Area of triangle ABC. So that is equal to determinant half times determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Let us substitute the values. So we get, I'll start from here, half times x1 is A, B plus C, 1, and x2 B, C plus A, 1, and C, A plus B, 1. Okay. Let's see. Half into, we will expand along the first row or the third column. Third column will be easier because all 1, so we can easily multiply. So then if we expand it 1 into, if you delete this row and column, we get B, C plus A, C, A plus B. Then minus 1 into, here plus, minus, plus. Then if we delete this row and column, we get A, B plus C, C, A plus B. Then if you take this plus 1, deleting this row and column, we get A, B plus C, B, C plus A. All right. Let's expand this. So we get half into here B into A plus B minus C into C plus A. Then here minus, if you multiply like this, A into A plus B minus C into B plus C. Then plus 1 into A into C plus A minus B into B plus C. Okay. I am sure if we expand this and multiplying the letters inside this alphabets in this way, and then it will all get cancelled. It will get all cancelled. So we get 0. So in that case, here we are having the area of triangle as 0. So what can we conclude? Therefore, the 3 points are collinear. This is very important, you have to write at the end. The conclusion is very important. We have to give the relevant answer at the end. So yes, the triangle, area of the triangle is 0, the 3 points are collinear. Okay. So in this session, we learned what is the determinant and how to find the value of the determinant of order 1, order 2 and order 3, and we also learn how to find the area of the triangle using determinant and collinear and area of triangle given, then how to find the value of vertex. You can try by yourself, and the exercise problems are easier. With this knowledge you will be able to solve it. Yeah, if for any query or any help, you may contact me through this email ID tpungudi90@gmail.com. And in the next session, we are going to learn the properties of determinants. It's a very important topic. Usually there will be a question from here, a 4-mark question. So try to listen that session very carefully. Thank you.